Okay, this is the second lecture for Introduction to Thermal Fluids. And we're going to continue with the discussion of comparing different types of fluids. Different properties that separate or have different fluids will have different properties. Last time we covered viscosity, and hopefully you had performed your homework assignment so you get a better, comfortable feeling of dealing with what viscosity is. Alright, today's lecture we're going to continue with fluids. What's the difference between fluids? Last class again we discussed viscosity. And again, homework assignment and watch the demo. You can see how different fluids react differently under different situations. Shear stress related to viscosity. Another material property that's very, very important that you are probably very, very comfortable with is going to be density. Density is going to differentiate between different types of fluids, different types of liquids, and different types of gases. They're going to have different densities. Density is going to be the mass over the volume. And the units of mass in the SI system are kilograms and meters cubed. So these are going to be the units, those are going to be the variables. Now, more than likely you have dealt with density as the letter D. However, grown-ups and adults represent density as the Greek letter rho. Now, I had a college professor that pronounced it and emphasized the rho. So, density, rho, is mass over volume, which in units of the SI system are kilograms per meter cubed for density. Now mass is the quantitative amount of matter in a particular location. Volume is the space, the three-dimensional space that it takes up, that it exists in. So the density of a particular substance is the kilograms per meter cubed. Now you can measure volume in liters, such as if you go upstairs or you go downstairs or go to your refrigerator, and whether you're at work or at school, you can get out a 2-liter bottle of soda. In there, that container takes up the space of 2 liters. So last class we went over viscosity, the dynamic of viscosity. And that was our Greek letter mu. We can create another term of viscosity, and we're going to call this kinematic. Kinematic viscosity, given by the Greek letter nu. Now do not confuse that nu with the frequency of an electromagnetic wave. You should have learned in your chemistry or physics class, and learn this little, whatever you want to call it, you can go up to your friends and you can go, hey, what's new? And they can say whatever you want, and you say, no, it's C over lambda. Or if your friends come up to you and they say, hey, what's new going on with you? You can always say, C over lambda. Or C is the speed of light, lambda is going to be the frequency. But that's a different subject. That's going to be more in physics or chemistry. But anyways, in thermal fluids, nu is going to represent the kinematic viscosity, and it's going to have units of meters squared per second. Kinematic viscosity is the dynamic viscosity divided by the density of the fluid. Okay, you can watch the demo for this class where I take this data that I'm going to present on the board that you're going to use for your calculations. So your homework assignment is pick the same 3 non-toxic fluids and calculate the density. And then compare with reported values and calculate percent error. And again, videotape your experiments if that's what your person that's going to be grading the subject to verify that you've done the work. Alright, the value that I'm going to be using for the practice calculation of density and percent error are going to be acquired from the demonstration slash lab that is done. So watch that before doing these, or you can watch it and then refer back to the calculations. But the demonstration is going to teach you how to take the data and collect the data in this homework assignment slash lab. Okay. So, from my experiment, measured the force of the cup, which was 0.040 newtons. And then I had chocolate,